exercise 6.2, sixth one. We have to find the intervals in which the function is strictly increasing, strictly decreasing. So consider this function f of x equal to minus 2x cube minus 9x square minus 12x plus 1. So first we have to find the derivative f dash x. So f dash x equal to minus 6x square minus 2 into derivative x cube 3x square minus 6x square minus 9 into 2x minus 18x minus 12. That is the derivative of f of x. Now we have to find the values of x for which f dash x equal to 0. So f dash x, we can write this in the factorized form. So it is easy to find the values of x for which f dash x equal to 0. So write in the factorized form. So here minus x is common. Minus x into x square plus 3x plus 2. Now again we can factorize, that is equal to minus 6 into x plus 1 into x plus 2. So 1 into 2, 1 plus 2, 3. So we can, we wrote in the factorized form. Next we have to find the values of x. So f dash x equal to 0 implies what are the values of x for which derivative equal to 0. So derivative equal to 0 means this equal to 0 implies what are the values of x. So this equal to 0 means x equal to minus 1 or x equal to minus 2. Therefore that implies x equal to minus 1 or minus 2. So directly we can write, if you always write f dash x in the factorized form. So directly we can write the values of x for which f dash x equal to 0. So we got two values and the domain of this function, this is polynomial function. So domain is set of all real numbers. So we have to divide the set of real numbers at these 2 points. So consider the interval. So splitting the interval into different parts. What are the intervals we get? Minus infinity to. See, we have to write in the increasing order. So minus infinity to minus 2. Minus infinity to minus 2. Then minus 2 to minus 1. Then minus 1 to infinity. These are the intervals we have to consider. So at these 2 points, we have to split the interval. Minus infinity to infinity. Now here. Minus infinity to minus 2. We know this in the increasing order. Minus infinity, minus 2, minus 1, infinity like that. So now consider first interval minus infinity to minus 2. So in this interval we have to substitute any number belonging to this interval in the derivative f dash x. So when between minus infinity minus 2, that means minus 3 we can substitute. Suppose we substitute x equal to minus 3. What we get f dash x? F dash x equal to minus 3. Minus 6 is negative. So negative into, then here minus 3. X minus 3 plus 1, that is negative. Then minus 3 plus 2, that is also negative. So negative into positive, positive into negative, negative. So that is negative, that is less than 0. So that is equal f dash x, that is f dash x less than 0. Therefore we can write, so when we substitute x equal to minus 3, we got f dash x less than 0. Therefore, in this interval, f is strictly decreasing. Strictly decreasing. Now consider the next interval minus 2 minus 1. Consider the interval minus 2 minus 1. So this is f dash x. Now next consider the interval minus 2 minus 1. Minus 2 minus 1. Open interval. Because we want strictly increasing interval in which function is strictly increasing, strictly decreasing. So this at these points minus 2 and minus 1 interval should be open. So here all open interval. Now consider any point in the interval minus 2 minus 1, that is minus 1.5. So when we put x equal to negative 1.5, f dash x, what is f dash x? Here x negative. So negative 6, that is negative. Then negative 1.5 plus 1, that is negative. Negative 1.5 plus 2, that is positive. So negative into negative positive, therefore that is f dash x is less than 0. So that is negative into negative positive. So positive into positive, positive. Therefore f dash x is greater than 0. Therefore f of x is, then one more interval we have to consider, negative 1 infinity. Therefore f is strictly strictly increasing. So in the first interval, function is here. First interval strictly decreasing. Now we got strictly increasing. Now one more interval we have to consider negative 1 infinity. Negative 1 infinity. This is f dash x. Negative 1 infinity. So in this interval, between negative 1 and infinity, we can substitute any number belonging to this interval in f dash x. So minus 1 to infinity means we can substitute 0. Minus 1, 0, 1, 2 like that. So 0 we can substitute. When x is equal to 0, f dash x, substitute in this f dash x. When x is equal to 0. So my negative, this is negative, negative into 0 plus 1 positive into 0 plus 2 positive. So negative into positive, that is negative. That is negative. Therefore f dash x is less than 0. Therefore f dash x is less than 0. Therefore f is strictly decreasing. Strictly decreasing. So in the interval minus infinity minus 2 strictly decreasing, and next minus 2 minus 1 strictly increasing. Negative 1 infinity function is strictly decreasing. So we got the answer. Now consider question number E. F of x equal to x plus 1 whole cube into x minus 3 whole cube. Now here, see this very important question. F of x equal to x plus 1 whole cube into x minus 3 whole cube. Remember that always write f dash x in the factorized form. So first find f dash x, derivative. F dash x equal to, here we have to apply the product formula. So first function into derivative of second. That is derivative x minus 3 whole cube. That is 3 into x minus 3 whole square into derivative of x minus 3. That is 1. Plus second function into, that is x minus 3 whole cube into derivative of first. That is 3 into x plus 1 whole square into derivative of x plus 1. That is 1. So derivative over. Now we can take, we want to write in the factorized form. So take the common factor in these two terms. So here it is common. 3 into x minus 3 whole square into x plus 1 whole square is common in both the terms. So taking common factor, we get here remaining only x plus 1 plus here remaining x minus 3. So we get x minus 3 whole square into x plus 1 whole square into x plus x, 2x minus 2. That is equal to 3 into x minus 3 whole square into x plus 1 whole square into 2 into x minus 1. That is equal to 6 into x minus 1 into x minus 3 whole square into x plus 1 whole square. So we got the factorized form of derivative. So we got f dash x in the factorized form. That is 6 into x minus 3 whole square into x plus 1 whole square into x minus 1. Now we got, now directly we can write the values of x when f dash x is equal to 0. So now we can write f dash x. F dash x equal to 0 implies, directly we can write, see which are the values of x? 1, 3, negative 1. X equal to 1, 3, negative 1. These are the values of x. Now we can consider the intervals. Split the set of real numbers into different intervals. So minus, increasing order we have to consider. So negative infinity, negative 1. Then negative 1, 1. Then 1, 3. Then 3 infinity. So these intervals we have to consider, and we have to check at in each interval function increasing or decreasing. So this is f dash x. This we need. We have to substitute the value of x in the derivative to find out whether the function is strictly increasing or strictly decreasing. So here we need this derivative. Now we can substitute here in each interval. We can check whether the function is strictly increasing or strictly decreasing. So consider the first interval negative infinity, negative 1. So in this interval, we can substitute any number in the interval negative infinity, negative 1. So for example, negative 2 we can substitute. So when we substitute x equal to negative 2, f dash x, what is f dash x? Negative 2. See, this is positive. Negative 2 minus 1, that is negative. Negative into. Negative 2 minus, here both these terms will be square, whole square. So that will be positive anyway. So only negative into positive, that is negative. That means it is less than f dash x is less than 0. Negative means f dash x is less than 0. So f is strictly decreasing. Strictly decreasing because it is less than 0. Now consider next interval minus 1 to 1. So we can put x equal to 0. 0 is in the interval minus 1, 1. So f dash x, what is f dash x? See 0 minus, this is positive, 0 minus 1 that is negative. And these all will be positive. So we get negative that is less than 0. F dash x is less than 0. Again consider, therefore f is strictly decreasing. Decreasing. Now consider next interval 1, 3. In the interval 1, 3, if put x equal to 2, then f dash x, what we get f dash x, x equal to 2. Substitute x equal to 2 in f dash x, 2 minus 1, positive. This is already positive. So we get positive, that is greater than 0. Now one more interval. So f is strictly here, f is strictly increasing. F is strictly increasing. Now we got in the interval 1, 3 function is strictly increasing. Now one more interval we have to consider, that is 3 infinity. So consider the interval 3 infinity. So in the interval 3 infinity we can put x equal to 4. 4 minus 1 positive. These are all positive. So x equal to 4, f dash x is positive. That means greater than 0. Therefore, in the interval 3 infinity, function is f is strictly increasing. Increasing. So we got in the first two intervals, minus infinity, minus 1, 1. It is strictly decreasing. And next two intervals, that is 1, 3 and 3 infinity, function is strictly increasing. So that is the answer.